Okay. Good morning, everybody. Thank you for the kind introduction. My name is Hannah, and today I will be presenting my topic, which is titled 10,000 Social Brains, Sex Differences in Human Brain Anatomy. So around 20 to 30 years ago, scientists have begun to question why primates have such unusually large brains for their body size in comparison to all other vertebrates. And so thus the social brain hypothesis came about, which states that the primate brains probably co-evolved with the selection pressures, or they co-evolved with the cognitive costs required to maintain increasingly large groups. And so it is selection pressures from social interaction rather than from the physical environment that has led to the continuous refinement of primate behavior. And so early studies have looked at group size as an indicator for the social brain hypothesis, and this is probably because the cognitive costs of sociality have placed a constraint on the number of people or individuals that can make up a coherent group. And so studies have really looked at group size and found that larger brains were associated with bigger group sizes. And so there are also studies done in humans, which also found the same results. And one study looked at the number of Facebook friends, and they found that more Facebook friends was associated with larger brains. And another study looked at real-world network size. There are other indicators that offer support for the social brain hypothesis, which includes the average grouping click size, tactical deception, and intentionality. And so along the lines of the social brain hypothesis, there is accumulating evidence that sex differences in behavior may also be associated with brain size. And so on the male side, one study found that it was larger brains that were associated with mating success rather than their rank in a group. And looking at females, this is a little bit a different story. Non-human primates, female primates, they form very close social bonds with each other because this has evolutionary benefits such as higher infant survival rates as well as protection from predators. And so with this in mind, a study looked at female group size and found that it was female group size rather than male group size that was associated with larger brains. And so that leads us to, so what I just explained to you now were all studies done with non-human primates, but that begs the question, what does this look like in humans? And more importantly, what does this look like in the brain? And are there other aspects of social interaction other than group size that can relate or be associated with brain volume? And so what we did exactly that. We used the UK biobank, which is the world's largest biomedical database, with over 10,000 participants aged 40 to 69 years old. And from the UK biobank, we considered 3 different groups of social variables that relate to social interaction. These were social aspects of social interaction in the family, outside of the family, and socioeconomic status variables. And so we looked at gray matter brain volumes because we wanted to look at the possible consequences of long-term plasticity effects, so the push and pull of various nature versus nurture processes. And so to put it more concretely, we wanted to delineate the degree of divergence in region and network social brain morphology between males and females in the context of various social affective traits. And so to do that, we used a recently available social brain atlas, which was published by our group. And this study synthesized almost 4,000 studies with over 28,000 participants, and they found that there are 36 regions that make up the social brain, and that they are divided into 4 core networks. And so I just wanted to briefly mention the data analysis, how we conducted our study. And so we implemented Bayesian hierarchical modeling because we wanted to directly interrogate the population uncertainty intervals of brain volume variation in the context of various social affective traits. And the reason why we did this is because we wanted to look at how much males and females differ in the brain, and we didn't want to look at direct our attention to only mean differences in volume alone. And so one advantage of our modeling approach is that we can use prior knowledge and research on brain areas. So I mentioned the social brain atlas. And we can use this valuable knowledge to look at between and within network volume effects, because in our model, we were able to put all 36 regions into one model. And in this, we can look at volume effects at the region and network level. And another advantage of our modeling approach is that we were able to borrow statistical strengths between clusters of individuals. So we meaningfully stratified our 10,000 participants into 4 different groups based on sex, so male and female, and whether they had the presence or absence of a social trait. And so together, our analysis, or our modeling approach, opens a new window into how males and females are similar or different in the social brain, and we provide a fine-grained morphological approach, or looking at brain volume variation in population, sex divergences, and different social contexts. So I mentioned that we put all of our 36 brain regions into one model, but today what I'm going to be showing you are just results that we have from the reward system. And so for each social variable, we have volume effects in all 36 regions. But here I will be focusing on the nucleus accumbens. And the reason I do this is because we found a consistent pattern of results across the 3 different groups of social variables. So if you direct your attention to the left-hand side, you see 4 different box plots. So I mentioned that we divided our participants into 4 different groups based on sex. So the pink colors refer to their females, the blue colors refer to males. And so if you look at the lighter colors, so lighter pink and lighter blue, these are we call them, just for simplicity purposes, the unsocial females and unsocial males. So these are the individuals that have a less rich social environment. And then the darker colors, so the darker pink and darker blue, are males and females who have more rich social interactions. And so looking at the left side, we see that depending on whether our participants grew up with brothers or sisters, we see that there is a volume effect in males who did not grow up with brothers or sisters. You can see that in the light blue. And we see that they show a volume divergence in the nucleus accumbens compared to males who did grow up with brothers and sisters. And you can see on the left that the female groups overlap in distributions. Looking to the right-hand side at social support, you can also see that this effect is very similar. We see that the unsocial males show a volume effect in the nucleus accumbens compared to males who do receive more social support. And again, we see that there are overlapping volume distributions in the nucleus accumbens in females. And so I forgot to mention that these 2 variables were part of social aspects relating to the family. And so what I want to show now are aspects of social interaction outside of the family, so such as the number of Facebook friends. So looking at friendship satisfaction, we again see this pattern of findings that males, the unsocial males, show a volume effect in the nucleus accumbens compared to the social males. And then we again see in the pink, so in the female groups, that they have overlapping volume distributions. And so directing your attention to the right-hand side, looking at sports club membership, we also see this pattern of results that males who are not members of a sports club, they show a volume effect in the nucleus accumbens compared to males who do belong to a sports club. And again, females are overlapping in their volume distributions in the nucleus accumbens. Moving on to our last group of social determinants, we are looking at aspects of socioeconomic status that relates to social interaction. And so you can see on the left-hand side, looking at income, unsocial males, so males who are lower in socioeconomic status, also show a volume effect in the nucleus accumbens compared to males who earn more. And again, you can see that there are overlapping distributions for the females. And the same effect is repeated in the type of health care. So males who had private or public health care, they also show volume divergence in the nucleus accumbens compared to males who pay into private health care. And again, overlapping distributions in females. And so what I just showed you now across these 6 different traits is that there is a consistent pattern of results in the nucleus accumbens for unsocial males. And we see that And what I also showed you is that our study provides also within sex variation, so between the male subgroups, depending on the richness of their social interactions, we see within sex differences. And in the nucleus accumbens, we can see that females are very similar in their volume distributions. And so going back to my first slide, I talked about the social brain hypothesis and how these early studies who looked at non-human primates, they focused their attention on group size as an indicator for the social brain hypothesis. However, what we did is that we looked at humans, and we can also broaden the scope and provide evidence that it's not only group size, but also other aspects of social interaction that contribute to different brain sizes, and that there is also a sex-specific impact. And so I would like to thank you for your attention. I would also like to thank my supervisor, Danilo Bustak, and Professor Joe Cable, my second supervisor, and Robin Dunbar at the University of Oxford. And if you have any questions, you can please come to my poster today at number 828. So thank you very much.